So now we're going to move on to understanding invariant points and how that can give us information about the translations. So here we're going to look at number 7 on page 29. And 7 implies that there's only a stretch, but I want to talk about the invariant points so we can actually understand how, without that knowledge, we can determine that a stretch is happening or a translation is happening, depending. So if we look here, we have two invariant points, which is -2, 0, and negative or +4 and 0. So these points occur on both f of x and g of x. What this tells us is that we can't have any kind of horizontal or vertical translation. Because if the difference between 2 and 8 were, say, a vertical translation, if it was a translation of 2, then these would both have to be moved up 2. But in this case, they're not, which tells us that there's no translation in that way, which means that the only way that we can go from 2 to 8 is by stretching it. So we can just easily go 2 or 8 divided by 2 to get 4, meaning that we have a stretch value of 4 in the y. So when we write g of x in terms of f of x, our a value is just 4. Or in other words, g of x is equal to 4 times f of x. Now if we look here at 7d, we see one invariant point, and that is at x equals 0, or the y-intercept. Now this tells us that we have no translations in the vertical or horizontal, meaning that what we have here is either a reflection or a stretch or whatever. So now, one thing that kind of gives it away is that all of these points are virtually the same, or not virtually the same, they are the same y values, meaning you could actually draw a line in between all of the points and they'd be at the exact same y value. So what this tells us, if we have all of our x values, so if we were to make a diagram, we have 1, 0. We also have +1. We also have 2 and 2. And then we also have other things. So on our new graph, we now have -1 and 0. And we have -2 and 2. And so you can essentially see that what is happening here is just our x value is changing signs, which means that we actually only have a reflection along the y-axis, which means that our x values are changing. And so because our x values are changing, that means that, again, if we're wanting to write g of x in terms of f of x, we flip the sign of all of our x values, okay? Which tells us to put the negative there. But that would be our final equation. And so another way that you could do that is you can just look at, because again, we know that there isn't any translations, we can look at the points as we did here and just recognize, oh, this distance is the same as this distance and they're the same y. Or we can look at any of these points and do that, or again, we can kind of make ourselves some diagrams. But that's all for now. And again, if you're wanting any customized help, you can just click the description below.